Hello and welcome to the OLM Working Group meeting. Today is Thursday, April 8th. On the agenda for today, we have several items. First one is from Chris on multi-namespace operator groups being deprecated in OpenShift. Chris, would you like to speak to that?
Yeah, so I brought this up a couple of weeks ago, and I guess I didn't get a satisfactory answer, so I'm going to keep harping on it again. So I really want to know why multi-tenant. And generally I know why we don't want to install, why it's hard to install multiple instances of an operator on a cluster. And the reason given last time, which is a good reason, was oh, am I back?
Yep, now I can hear you. I can hear you.
Okay,
You disappeared for a while there.
Yeah, all of a sudden my Zoom just kind of disconnected and reconnected. Okay, let me figure out where I left off. So what I can't figure out is, so I know what the issue is with having multiple instances of an operator running. What I don't know is why multi-namespace or multiple targeted namespaces is in an operator group is bad, even if you have one operator. So we really, really want to use this so we can have basically, we do want to use it for multi-tenancy, knowing what the sharp edges are, right? So if we try to stay away from conversion webhooks, we try to stay into the things that we know are good. For example, we maybe limit everybody into the same set of channels in the operator instances to make sure there's no conflicts with the CRDs. Try to use OLM the way it was meant to be used and not use any of the things that make it hard. Is there anything that I'm missing? So why is multi namespace operator group mode? Why does the OpenShift documentation say you shouldn't use it? Because it seems like the multi-instance use case last time doesn't really apply.
So there are a few issues. I think one that we haven't really talked about much in this setting before is that it really doesn't work well with the kubelistwatch APIs. So when you set up an operator that watches 20 namespaces, the only way it has to do that is to set up 20 watch connections with the server to do a normal, if assuming you're using the standard like client Go machinery that sets that up. There's no way to ask Kubernetes to give you a watch over a set of n namespaces. So you're always going to be doing, something around those to work around it. So if you're already, resigned to dealing with a bunch of restrictions around how you deal with multi namespace operators and the things that you want out of that, it seems like you'll have a much better time if you maybe move that some into the application layer and have just a cluster scope operator that controls that, maybe controlling different controller versions internally or something, but sharing the same watch cache would be one approach. Or
so
depending,
can I elaborate on that a little bit? What about the Ansible operator? So Ansible operator supports the watch namespaces. Has it taken care of all of that complexity from us if we use Ansible? Or does it not quite work right either?
So there's a few things that abstract it. Ansible does it. I see Eric's on the call. Maybe he can remind me if the Go version of SDK supports a multi-namespace watch. I don't remember if it does. But all of those don't get around the fundamental it's an API server limitation, right? I can't make a connection to the Kube API server and ask to get events for a set of namespaces. I have to, if I want to watch 20 namespaces, I have to make 20 connections, 20 watch connections. If I want to, the only thing that you can do to get around that is request all namespaces, and then you'll get the events for all, and then you can filter out what you don't need.
Yeah, that's correct. So the Ansible operators watch namespace environment variable is just to configure the underlying controller for the Ansible operator, which is effectively just a Go operator to set up a multi-namespace cache. So yeah, you're effectively seeing the exact same problem in this situation.
So it's really a scalability problem.
Yeah, and I think for live production clusters, especially multi-tenant, you're going to see a lot of namespaces, and cluster admin is going to want to configure a multi-namespace operator to watch a specific set of namespaces, but it's going to be big. That set's going to be really big, so you might as well just make it a cluster scoped operator, and then use something like a predicate to filter which namespaces the reconciler actually reconciles within the controller. So I think one nice thing we can do here is implement the same pattern, but for using that predicate and making it really easy to create that predicate for an operator for Ansible, Helm, or Go, and provide that in a library, and then also give guidance on like why multi-namespace configurations from a like bundle level are bad, and why you should use this library function instead, and encoded in application logic, like Evan was saying.
Yeah, can you elaborate on doing it in application logic? I'm missing something there. So I'm thinking what you're saying is you basically configure all namespace mode, right? So then you just have one connector just watching all namespaces, and then you just filter it on the event calls. So you just get called all the time and you just filter it out.
I think saying application layer is a little bit misleading. It's more like you encode this logic within the operator itself rather than the like package deployment method. But yeah, that's effectively what I'm saying. You filter the list of events based on namespace within the operator itself rather than on like a deployment package level.
So is that how the Ansible? So how does the Ansible implement it? Is it implemented by establishing a different connector for every single namespace then, or is it doing it this other way?
It's for all operator types. It's done in the exact same way because you have to establish a list watch in the exact same way.
I'm still confused. So, but not in all namespaces mode though, right?
In any mode, like everyone was saying, this is like an API server limitation. You can't aggregate list watches, even if, like for example, if you're just curling like the API server REST API to establish a list watch, you would have the exact same problem. So it doesn't.
Well, then how? So does all namespaces have a mega problem then? So all namespaces mode is horrible because it's going to automatically listen to hundreds of namespaces and get called all the time?
No, so from what I understand, you would establish like a global list watch, and it's just one.
Yeah, that's what I'm saying. So you basically have two modes: a global list watch and a single namespace list watch, of which you have to have a bunch of those, right? So yeah. That's why I'm asking. In the Ansible operator, did it implement it as a global list watch and put it in the application layer, or did it do it the per namespace list watch?
It depends on what you set the watch namespace environment variable to. If you set it to the empty string, then it will create a global one. If you set it to one or a list of namespaces, then it will make one or a list of, or a set of list watches. So
well, but I'm asking
my point is that because, sorry, go ahead.
I was just going to say, so in the Ansible operators implementation, it made a choice to do it that way? Could it have made a different choice to just watch, if you specify 2 namespaces in the watch namespaces environmental variable, could it just watch them all and discard all of them but 2? Could it have implemented that in its application layer?
Yes.
But it doesn't.
Yeah. Because
Okay.
I guess like you don't want to like necessarily hide what's happening, because in that sense, because if you do that, then you also have to somehow inject a predicate, and then you get all this, like you could potentially get a lot of like API server traffic that you weren't expecting, right? Because you're establishing this local list watch and you're creating a predicate which is completely client side filtering. So it's effectively like hiding complexity for like a really big gain in runtime, like performance overhead. So the design choice is made so that the user knows, like the developer, the Ansible operator knows explicitly the performance trade-off that they're making. I don't think also that there is a way in Ansible operator to create a predicate, although I'm not 100% sure about that. But yeah,
So
like
I'm
the
missing
point
something. So
being is
when
that,
you
go
say
ahead.
predicate, what do you mean?
A predicate is you could just think of it as a filter that you apply to the stream of events coming from the API server based on your watches. And it's completely done on the client side. So you can apply like a field filter, label filter, basically anything you want on a particular object type. And you assign that, you register that with the operator's manager, and it will run that predicate filter on all of the incoming events.
So I guess what I'm after is, does it make sense to improve the Ansible operator to be allowed to specify different implementation alternatives depending on, like, for example, if you have a watch namespaces environmental variable set to 100 namespaces and you only have 200 namespaces in your cluster, then automatically switch your implementation to do a global watch list rather than like a per connection
Yeah.
watch list.
I see what you're saying. And like, yeah, totally. That maybe not that specific like bit of logic that you just described, but something very similar. Yes. And I think the whole, like going back to the OLM side of things, the whole like efficiency problem is caused because you can specify to OLM, like use these exact namespaces and inject that into the operator in an environment variable and let the operator decide how to establish its list washes. And we should give that control to the operator developer for Ansible and Helm operators. For Go, you can do whatever you want pretty much because you have
Sure.
access to the Go APIs to do that. But for Ansible and Helm, that is not the case. So yeah, I agree with you.
So is there some sort of tipping point where, so obviously 1 namespace, everything's good there. 2 namespace, a little bit worse. So when I'm talking about my scenario of having multi-tenant operators and operands, we're not talking about, dozens and dozens of namespaces. I'm talking like maybe a half a dozen, up to a dozen, something like that. It would be fairly reasonable. So of course, customers can abuse this like crazy. So we need to be careful. But I think we have that problem anyway.
So I don't know at what point performance really degrades. I think it is some function of the total number of namespaces versus like how many you're actually trying to target. I don't really know. I don't have the insight to that. Evan, do you know?
No, I don't know off the top of my head.
Yeah. I guess the real question is if a few can cause performance overhead, like even like 3 or 4, regardless of how many namespaces exist in the cluster, then no, like all namespaces is not good ever, effectively. But if it is actually some function of the total number of namespaces, then you can get some sort of like upper bound on at what point you switch over to a global global list watch, then yeah, you can make some inferences about that. But I think the real problem is like there is no good way to know because it really depends on what like a lot of different factors, especially like the amount of like CPU power that you have in your cluster and memory and things like that. There's just like so many variables. So I think the reason why this choice is being made is because you just can't know. It's better to configure an operator to list watch all namespaces in the cluster and then filter that client side. It just makes like weird performance bugs go away in a lot of cases.
All right, so would you recommend that I open up our RFE against the Ansible and Helm operators to try to give us a few more knobs to be able to do a global list watch with the client side filtering?
Yeah, so I
That
think
makes sense.
Specifically, I would love to see a request for an environment variable that lets you configure or some configuration option that lets you configure a predicate. Or I would like to call it a predicate on the API side of things, and then document that it's like a filter effectively that's applied to incoming events. And that way we can pretty easily show how to set up this pseudo multi-namespace installation mode. So yeah, go ahead and do that if you can. That'd be awesome.
Yeah, okay. All right, I'm glad I teased that out. Connection per namespace. Okay, all right, that answers that part of it. So Evan, you were going to say there are other ones. Are there other issues with the watch namespaces with more than one? Go ahead.
The big one is going to be the conversion that we've talked about in the past. The part of that I'm not sure that we've really gone into is that you can have conversion problems even without a conversion webhook, because you can in theory have two operators that let's say they use the same group and kind but different versions, disjoint versions. So we have one operator that manages v1, one operator that manages v2. It's perfectly fine to install two of those alongside each other, but Kubernetes will do the conversion for you, right? It'll give you all the v1 stuff at v2, and it'll give you all the v2 stuff at v1, and now you'll have two operators that are managing the same set of APIs, the same set of instances without realizing it.
Yeah.
So yeah, again, but that's still a multi-instance problem, right? It has nothing to do with multi-namespace operator groups, assuming you're using operator groups to manage operand namespaces, right?
You're right that it's a multi-instance issue. If you're only going to have one instance in the cluster, though, then it would be much better to make a all namespace operator and filter down to the set of namespaces that you're trying to operate in.
Yeah, I kind of get that. So yeah, this is what we talked about, the Ansible operator, and I'll create a RFE for that. Yeah, so for multi-instance, right, I get all the issues with that. And we've had some really clever products try to actually be smart and plug in the latest controller into the conversion webhook. So make sure the conversion webhook is always the latest version that understands all the versions it could be, right? And so it's got like a lease manager or a voting mechanism or whatever they've done to make sure that that happens. And of course, there's edge cases. What if you installed the most recent guy? And yeah, there's a bunch of issues with that. But it was specifically regarding multi-namespace watches. Are there any other issues other than the scalability problem you were talking about?
Just with multi-namespace watches, I can't think of any other issues, no.
So the OpenShift documentation specifically says don't use it. It doesn't really elaborate why. So we can probably fix that. Is there, in the upstream OLM, there is nothing talking about why this is bad. So is it in the intent to deprecate that, or is it just intent to educate people on how it's, you know, the problems with it? So if you're going to write your own Go operator, you know, make sure you do it exactly like how you said, do all namespaces and just filter, which means that's just an implementation detail. And this is the best practice for how you write one of these things. It really doesn't mean you should deprecate it.
So I think there's two different things going on. One is, how should you write an operator that can only watch a set of names, like a smaller set of namespaces than everything? The other side of it is the multi-namespace operator group specifically, and that is something that we do intend to deprecate. So the notices on the documentation about not using it are because we intend to remove that functionality, and that's because we're planning to go to this descoped scenario that we've talked about on this call before, in which would allow you to write an operator that watches a small set of namespaces, but it would not rely on any auto configuration from the OLM side, and it wouldn't attempt to understand the set of namespaces when it comes to install and resolution time. That would be a configuration of the individual operator. Does that make sense?
Yeah, you do it all with RBAC, right?
Yeah, that's the eventual goal.
With multi-namespace, isn't there a danger if the different multi-namespace groups overlap?
There is a danger, but OLM will prevent you from installing operators that manage the same APIs in overlapping namespaces. But if you're doing it
Right, so the
yourself,
operator,
yes, that would actually be an issue.
Right, so the operator group two operator groups can target the same namespace, right? But they can't own this overlapping namespaces. I think that's the bottom line, right? You can't own an API from two different namespaces. So
right, exactly.
Right. So you can have, like, for example, so Mike, the common services operator could watch 10 different namespaces, and then the Cloud Pak for Data operator could be in a separate namespace watching those same namespaces. Two separate operator groups, but they're still watching the same namespace. So I have a picture.
No, I understand the two
probably
different
help you.
operator groups.
Yeah.
I think it was within the same operator. Two different operator instances, which you can have today, installed in two different operator groups. If there's any overlap, then in that overlap, it would not be clear which operator, or maybe both operators, would be operating on the CRs. That's the thing I had in mind.
Yeah, I mean, in that case, one of them will get installed, the other one won't be able to. The second
Okay, so you're saying OLM will figure that out
later. Yes, correct.
Yeah. Okay, got it. Thank you.
I'm aware of that too. Yep. So yeah, so Mike, I guess where I'm getting at is I'm trying to understand some of the use cases we've got for multi-tenancy. You know, whether we go forward with the namespace scope operator, which has the exact same problem because it's going to have to watch multiple namespaces, or do we move forward with operator groups with this mode because it's the same problem either way, right? And operator groups, in my opinion, are nicer because there's some UI help there, and OpenShift also helps you. OLM helps you, get out of the accidental creating overlapping operator groups and so forth. So that's I'm kind of wondering. It's like, do we have? So I'm trying to figure out how to go forward because we have a lot of customers and business pressure to do multi-tenant operators, right? So operator groups, that's one thing. And then multiple instances of operators is another thing. So I think we've kind of figured out what, you know, the narrow path is that makes it that does work. So what I'm really concerned about is if we go forward with that and it's not really deprecated, right? It's just kind of says we recommend you don't use it. And so what's the danger? I mean, do you have any time frame on when that's going to go away, or is there going to be a natural migration path to move to the descoped version with some kind of controller tenancy concept? Because I know there were, I don't know, Evan or one of you guys put you know, different tenant controller kind of concepts in there. But it sounds, I'm not sure if you're going to have anything that's going to be first class kind of migration to that or not.
Yeah, the plan is definitely to have some migration help in place. But that said, I think there will come a state, there might be certain configurations of operators that we won't be able to automatically migrate. And one of those might be you have multiple multi-namespace operators running in a cluster. Because we won't be able to identify how the management of the CRD should actually happen.
Okay.
I guess
So
one
are
thing
you,
sorry.
go ahead.
It sounds like sounds like you're working through some design constraints and problems that we don't have a super clear picture of. I guess I would ask if there's a problem with having an all namespace operator and then filtering down which events it responds to, like Eric was talking about.
So OLM doesn't offer a way to do that. I mean, the Go operators would, right? Because your Go operators can be written however you want. I think the problem is that customers, you see the, I think the problem is all namespaces scope infringes on namespaces that the customers do not want the operator to operate upon. So the CSV gets copied in to those namespaces of which they would not like them copied into, right? So all namespaces scope is far too intrusive for a lot of customers. So in our case, we're going to have potentially suites of operators, or suites of products, which might have 30 or 40 operators that are installed concurrently and interoperating with one another. We're trying to use operators as the component, right? So the reusable component. And so we're trying to figure, and we're also trying to minimize the security domain of each operator. So we don't want to blindly install operators in the same namespace and then all operands in one other namespace, right? We want to be able to, customers really, really like security domains to be as tight as possible. And so by using all namespace, a lot of the permissions are promoted to cluster role bindings.
All of them
which
are.
customers, yeah. So customers really hate that. And so they absolutely say, I am not installing an all namespaces mode on this cluster, period. I'm not going to buy your product. So that's a huge problem for us, right? So we need a hybrid mode, which is basically we want to install like own namespace mode, but yet watch multiple namespaces, which is what this whole namespace scope operator we talked about last time does, right? So it kind of gets you that secured kind of bridge between those two concepts. But unfortunately, the UI doesn't work great because you know those operands are kind of hidden now because they're not copied. The CSVs aren't copied around.
Right. It also dynamically expands. So you can be watching two namespaces and then a third one gets added that you want to include in that domain, and you can dynamically extend its watch to that third domain. We're not doing anything secret here. We're just managing a config map that if you add another namespace to, restarts all the relevant operator pods with that namespace added to the watch list. So, but we do, we do run the risk and have to check to make sure that we don't overlap for the same operator in the same namespace. But it has that dynamic nature to it.
Yeah, so Mike, I think what I'm hearing is that so multi-namespace operator groups, not a great idea, and they probably should be officially deprecated if that's the intent in the upstream documentation as well as the downstream documentation, because it's not today. So make sure it's crystal clear to everybody, this is probably going to be going away. And then we probably should use own namespace mode for all of our operators, and then augment that with the namespace scope operator, which allows us to extend those permissions.
Right, which is pretty much what we're doing.
Yep. I'm just saying it out loud. I wanted to think about operator groups really deeply before I wanted to really understand what the problems were with that. And we've uncovered the major one, which is the connection problem. So just got to make sure all of our operators, when they're building it, build them a certain way, right? There's a best practice. And so, because our customer is definitely the big giant ones with the giant clusters, the 500 nodes are going to run into this pretty quick.
Yeah.
Yeah, I think.
Yeah.
I'm sorry. Go ahead, Mike.
I was going to say the descoped operator with RBAC would be a nice alternative, because you can manage that RBAC. You'd manage the RBAC, and then you'd have fewer operator instances, right? In other words, why install more than one operator that's at the same level if you can control that one operator's watch scope? The reason we do it today is because we don't want to escalate the cluster permissions to put it in all namespaces. So we install individual operators in each namespace to maintain isolation in those namespaces from a security perspective. So there's a lot of advantages to the descope. Yeah, okay.
Yeah, I think another thing, Mike, that we probably should do is stop promoting multiple instances of operators. So we should really start having this singleton namespace concept, because I think this is going to just be a problem for people because they won't be able to move forward anyway. Get used to the idea of singleton operators.
Yes.
Know what I mean?
Yes, I think that's what we're thinking about. And I know that there's definitely going to be a transition period. I think the operator pattern, Evan, and others will say, like, evolved from where it started to where it is now. And there's, lessons learned. And I think this is one of the lessons. And we definitely need to focus on, documentation and like that transition path forward. And right, like things like the predicate library and things, but we are sort of like as sort of the experts in the sense that we work on the operator framework, collaboratively we're all working on it. We need to kind of move in a path that we think is the best given the underlying limitations of the Kubernetes platform. Like, I think we were hoping for any kind of multi-tenancy movement on the platform level, but we didn't really get it. So based on that, this is, I think, the direction. And I think there needs to be a lot of community effort to demonstrate this direction as we prototype it out. The other thing I want to just point out quickly is like things like CSV copying would also go away in this world. And there's like, some of the APIs would change and go away. So I just want to point that out. So it's not like we just make cluster scoped operators, but everything else is the same. It's really quite a big difference from where we're at today.
Yeah, the only other thing I can think of is that if you install two products it's the same product in two different namespaces for two different groups, but the operator is the same for those two different products and those two different groups, it would have permissions across those domains. And some customers, because of their current conditioning, might see that as a security exposure. I installed this in, say I have a cluster where I have dev and QA, and I install an operator for a product that I'm using in dev and in QA. So they would want those two namespaces to be completely isolated, yet the operator now has, wherever it is, has the opportunity to create or see or watch resources in both of those. And that would be a model that would be new to them, right? And so I think we'd have to do work on ensuring that they understood that either was or wasn't compromising the security as they know it. They actually have gotten pretty used to and really like this. Operator runs in this namespace and only can affect things in this namespace. With a descoped operator, you now are installing an operator essentially at the cluster level and giving it permissions in the two different namespaces. But if those are two different tenants, two different organizations, then that operator has has authority over both of them. It's kind of like installing an application on, and these people come from this world, right? On two different virtual machines, you install the same application, but no, there's a third virtual machine that can control the other two, but those other two belong to two different organizations. Is that an issue? Right. So it introduces a new security model.
Yeah, I think the key there is that an operator is really an extension to the kube control plane. You treat it that way. You don't treat it as part of an application, right? You treat it as a management system for an application. And so I think that's the retraining we have to help.
Yeah, I think that being said, I think they have a tendency to trust the Kubernetes control plane more than they do trust the applications that extend it. So, one is more stable than the other. So I think you're right. But yeah, there would be a lot of re-education that goes on there.
I think there's a lot of good documentation we could do too. And some of this comes down to almost just definitional issues. Like if you have a dev and a prod namespace, you have a single operator, quote unquote operator, managing both of those namespaces, but those could be completely separate pods, completely separate service accounts that are managed, that together make up the quote unquote operator. The thing that they agree on is they have some understanding of how they will split up watching the namespace and interacting with the namespace, and they have some understanding of the shared APIs that they deal with.
Sure, that would take care of that situation. Yeah.
A few of these different scenarios come up from time to time, especially in this call. I'm wondering if we should just kind of keep like a running list of, here's an interesting deployment scenario with a hard edge with the way things are today. And then as we continue to work on some of the newer work in this space, we just make sure that we're not dropping any of those use cases on the floor.
Yeah, why don't you go ahead and do that?
Well, I took a stab at the reasons I think people want multi-tenancy and what they can do instead. But I would prefer like real customer cases, real user issues that we can catalog. I can certainly get some of that started with feedback that we get directly, but if you guys have any that you're getting as well, that would be super valuable.
Yeah, I guess if you want to, start a spot where you want to start collecting that kind of data, Mike and I and our team, we get, customer scenarios all the time, and we can start populating that.
Yeah, I'll take that as an action item from this and come back next time with one.
Cool, thank you. Is there anything else I need to know about as far as multi-namespace stuff that we would run into with our namespace scope operator other than the connection problem? Or is that really the biggie?
Depending on what you're doing and how you're installing things with OLM, it can be an issue for dependency resolution. If you have an operator that depends on a multi-namespace operator that is installed, but not watching the namespace that you need, or you have,
Right.
you're trying to install a cluster scoped operator, but something else is already installed at a multi-namespace scope. This kind of falls under the general scoping dependency resolution problems, but it is, I think it's harder to debug with multi-namespace operators.
Got it. Okay, I think I'm good, Dan. If you want to move on to the next topic.
Okay, great. So yes, we have about 15 minutes left. We have topics from John regarding some PRs to review. John, would you like to speak to these PRs?
Yeah, so I had a couple of PRs I'm trying to, push along, push over the goal line here. And the first one is this 260 or 2069 PR. In order to be able to make this work, one of the things that the context here is that this is the end-to-end test that we were talking about trying to submit. So this is about taking all the individual tools like OPM and whatever, and running those actual tools on the in the test environment, so you can create catalogs and test all the different scenarios that you can think of. But in order to do that, one of the scenarios that we have is that you go grab the downstream OPM executable and get that installed. But in order to do that, I need to actually have the credentials to actually access that. So the way I have that currently set up in the, I don't know if I could just share the screen just so everyone's seeing. Oops, it won't let me do it. So anyway, I guess the point here is that if you go look at that comment, in that comment, I've got a couple of environment variables that are being set through GitHub secrets. So there's a Red Hat password one and a Red Hat user password, or Red Hat user. And so that works in my system, but obviously that doesn't work in the actual repository because it's not set up. So what I'm hoping to do is, because I think this, since you all own the repo, I kind of have to rely on someone to actually make those secrets. So this is kind of my plea to say, what do I need to do? What password, what user and password should we use? Do you have something for Red Hat for a like a fake user, so to speak, or a bot kind of user, so that that has access, or what's your process for trying to insert those kinds of things into your build process? So I guess that's the question. What would you normally do?
Yeah, so I can speak to this a bit. First of all, it looks like a really impressive PR. I mean, to be able to build catalogs and stuff in the end-to-end test is something we've been trying to do for quite a while. So I definitely want to review I think we definitely want to review the PR. In terms of like secrets on forks of branches is a GitHub level like limitation. I guess my question to you, first of all, is why do you need the downstream OPM versus just the upstream? And in terms of like passing credentials on forks, we ran into that issue in the registry when we were setting up end-to-end tests. Basically, GitHub doesn't let, like, if we put secrets into the repository, they won't be accessible to CI that runs on forks of the repository. Those same secrets will only run against the main repository, so they would only run on merge commits to master. So that's my those are my 2 cents.
Okay. I mean, so to the point about why upstream versus downstream is that I know that we've had scenarios, and I think Chris can talk to some of those, but where there are differences in sometimes in the behavior between the upstream and downstream, and part of the being able to create the test is we can use the different tools for different installation scenarios, so that we can test out both of those paths for an upstream versus downstream, and make sure that things are working the way we think that they should be working. I don't have the exact scenarios off the top of my head, so I don't know if Chris has those either. But
Yeah, just real briefly, it's about interoperability, right? So there's all sorts of interoperability things that we've encountered between upstream versions of, the OPM, the registry server, and OLM, right? They've kind of settled because a lot of features have been kind of slowed down, but man, for a while they were really bad. And so we really wanted to have some capability in there to be able to validate that everything's working interoperability wise between those things. Does it make sense?
Yeah, I think that's really great. I first of all, I would just say that I think as in the context of the upstream downstream split, which is something that we've actually have done, this repository is now upstream only in the sense that we would prefer to test upstream only bits and really have upstream only bits. So it totally makes sense what you're describing between differences between upstream and downstream OPM. And I mean, there's a whole host of reasons for that. But that's one thing I would say is that I think if we want to add a test to operator framework / operator lifecycle manager that pulls in bits from operator framework / operator registry, those are both upstream projects and shouldn't be testing necessarily downstream OpenShift specific builds or components, is my understanding.
Yeah, second that. It's the same thing in the operator SDK projects. I don't know if OLM has a downstream repo yet, but when it does, then all of the code paths that use upstream images and binaries will be substituted for their downstream counterparts. So I wouldn't worry about using downstream in upstream. It makes it a lot more complicated and isn't necessary right now.
okay, I mean, I guess we can certainly remove at least the parts of the code, because right now they're just a script that actually just goes and tries to download all the various components and caches them in a GitHub cache. And so the only thing that would then need to be pulled out would be the Red Hat portion of the downstream portion of that. I guess the question then becomes, fine, let's say we do that. How if you're going to have downstream testing, how do we contribute to your downstream tests to make sure that things are actually working the way we'd like them to, or that they should work?
Yeah, so we have I put in the chat the downstream repository. It's under OpenShift and OpenShift / operator framework OLM. So that's fairly new, but we've got the sync going from the upstream to downstream now. And basically that is the place for downstream specific testing. So I think that in the case of additional CI, we can touch just the downstream bits there, and then the upstream sort of bits in the operator framework / operator lifecycle manager.
Okay, so then it's just a matter of getting the one PR set to just assume everything's upstream, and then when things get merged into the downstream, however that mechanism works, part of that will be to re-add that piece in, so that way you can actually get the right versions of the, so you can get the downstream OPM version and get that installed and use it, is what I'm hearing.
Yes, and okay. that should work fine. But I would still caution you on the using credentials and expecting credentials in forks. Is just generally like trying to extract with credentials. You might run into issues. I know we ran into issues with that. So it may be the case that it won't be able to the sharing credentials between the main repository and your fork of the downstream may be problematic if we were to check in credentials to do that.
Okay. Yeah, like I say, I think if we remove the secret portion of this, then I think that actually reduces or removes the need to actually have this, If you've got something set up in your downstream where you're dealing with secrets or however you're doing with your downstream pieces to deal with credentials, then you kind of move the problem away from upstream. So I can certainly remove the secret requirement here. Start with that, and then we'll try to figure out how to tackle the downstream in whenever we get this thing merged in upstream.
Okay.
Okay, so then for the 605 one, I think the only thing there was just basically, I think there, Vu had actually just approved the, so now I just need to review. I think that there's been a bunch of discussion going back and forth between myself and Tim and I forget who all else. But the point is that I think, yeah, maybe Joe, I think it's ready to go. So I guess I was just kind of, just seeing if there's anything else that needs to be done, or, just looking for the final review, I guess. I don't know if Tim or Joe or who's on the call, but
Yeah, I think I can ping the folks who have already been looking at it and say that it's looking for, an LGTM. And if it's approved by Vu, then I think it's pretty much ready to go. We just need one more.
Okay.
Sign off on that. Should be good to go.
all right, excellent. All right, that's all I had. Just thanks.
Okay, cool. I don't think we have anything else. We don't have too much time. About 5 minutes left, so I think we'll just call it here then. Thank you everyone for attending the working group meeting today, and we'll see you at the issue triage meeting next week. Bye everyone.
Thanks a lot. See you.